So here we have another rational equation. We want to find all the zeros. So if we can just find one zero and they tell us there's at least one rational one, think about what our rational zeros could be. Factors of this over factors of this. So we could have like 3 over 1, 1 over 1. We could have 3 over 7 or 1 over 7. And so if we look at our graph, those are the points I would try to look and see and test if any of those are zeros. Is you can start doing rational, take the possible rational zeros. So it looks something like this. I can see there's 3 zeros. I'm just trying to find out what they are. So try it out on your calculator, actually graph it. Because you can take all the rational zeros and start doing synthetic division to see which one works. But notice there's a few of them, and so you're going to get some that don't work until you find one that does. So graphing it gives you an idea so that you can find one beforehand. So graph it, figure out, try to test if those are zeros. So this one ends up being, it looks like 1/7 or -1/7. So once I know one rational zero from my graph, that's useful because now I know something that should divide in evenly to this. So synthetic division with -1/7. So write down my coefficients to get ready for synthetic division. And add, so 7 plus nothing, and then multiply. 7 times -1/7 is -1. And then add, so I get 7. And 7 times -1/7 is -1. And then add, I get -21. The negatives will cancel, so it'll be 21 over 7, which is 3. And so it looks like there you get verification that actually was a zero because it divided in evenly. All right, so why is that useful? Because now I know that if this is a zero, then x plus 1/7 would be a factor. And then I'm left with 7x squared plus 7x minus 21. And I can try to see if I can do anything with that. First thing I noticed about this, regardless of whether or not it's going to factor, it has a 7, and so I can pull a 7 out as the greatest common factor. That's usually useful because even if you do end up using quadratic formula, it might be easier to have a, b, and c be 1, 1, and -3 than it would be to do 7, 7, and -21. Alright, so it doesn't look like this one factors, and so I can just use quadratic formula because at least now it's down to something that's quadratic. So we're trying to solve this, make some room for quadratic formula. So b is 1, a is 1, c is -3. So negative b plus or minus, b squared is 1, minus 4, a is 1, c is -3. And then all over 2 times a, which is 2 times 1. So I have -1 plus or minus 1 plus 12, so square root of 13 over 2. So that's simplified all the way, so I just found my other 2 zeros. Even if they didn't work out nicely, I used the rational one to divide, and then that got me down to quadratic, then it was easier to find the other 2. So -1 plus square root of 13 over 2 is a 0. And -1 minus square root of 13 over 2 is 0. And because you had your graph open up from earlier, it'd be a good idea to go to your graph and check and make sure that those actually work.